Hello, everyone. I make that 5 minutes past the hour, so I think I'll start now. So this is the Archer 2 for package users course, and it's a course that's really intended for people who are new to Archer 2 and also new to HPC in general, in fact. So my name is Michael Bareford. I've been working at EPCC for a number of years, which has been an institution at the University of Edinburgh that have supported the UK National HPC resource for a number of years. It's Archer 2 now, but it was Archer before that. I will be helped during my course by Eleanor, who's also been at EPCC for, I don't know, for 2 years now, or maybe a bit longer. So now you should see basically I've got a browser open and I'm on the page which has all the course material for the Archer 2 for software package users. So I'll just start the course. We've got the main page, which gives you an idea of what's coming up of the schedule. So we've got 2 breaks basically and a lunch, and it runs between 10 and 4. I'll start it off on the welcome page of the course. So we have a code of conduct, and it just means basically there are a number of points, but it's all about you being nice to people, and I think you could sum this up as do unto others as you would have others do unto you, basically, and just show everyone courtesy and so on. So that's just like the standard thing that we have at the start of every course. This course structure is based on something called the Carpentries methodology. And all that means is rather than giving you a load of material and talking at you for a long period of time and expecting you to go away and do some exercises, we do the exercises as we talk about the information. So we have exercises or a question, like a multiple choice or something like that, and we can engage with you hopefully throughout the course. As we go through the various parts of this course. We also have plenty of opportunities to give feedback. You can do that during the course, of course, but I think there will be an actual form on the webpage which you'll be invited to fill out, and you can do that when it's convenient. Of course, we're very keen on feedback because this is how we improve our training materials and the way we give the courses. So now we'll get on to connecting to Archer 2. So I don't know how many of you have, in the days before this course, maybe last week, you managed to create an Archer 2 account. Has anyone actually done that? So this would involve creating an account on something called the Safe, which is a website service that we provide that allows people to create and manage their user accounts on the various HPC machines that we support. Has anyone done that? Just if you say yes in the chat, or yeah, so a few people, well, 2 people, 3 people. So I think that's most of you. That's good. But if you haven't, that's okay. We can just help you how to do that. So you probably know then, as you've tested your login, that's the login address for Archer 2. It's quite easy to remember. We basically, we have 2-factor authentication, a password and a passphrase protected SSH key pair. So you would have gone through the process where you created an SSH key on your local machine, and then you would have uploaded the public key to your Safe account, such that it would be associated with the Archer 2 machine account. And then when you log in, you're prompted to change your password immediately. So you would have been through the process also of viewing your initial random password from within Safe also. So there's a on Archer 2, we run it, but we have a particular policy, and you can find out the details by clicking on this link here. And so what this is that it says that the minimum password length has to be 18 characters. That you get credits if you make your password more complicated, or if you choose certain character types, and it allows you to reduce the length of the password that you need. So each credit basically maps to you can reduce your password by that number of characters. So if you have lowercase characters, you get 2 credits, and you get 2 more if you have uppercase, and so on. So this means you can have a password length that is between 10 and 16 characters, but depending on whether you've got numerical characters or punctuation and so on. So we've got a first question here to see if you kind of understand that. So out of these 4 passwords that you can see, these 4 candidate passwords, my password, rainbow llama jumping, the unpronounceable one, and horse battery staple, which of those 4 would be acceptable, would pass the Archer 2 password policy? Just so if you can type the number of the password that you think is acceptable in the chat. Okay, thank you. Yeah. Yeah, so I got 3. So 3 is correct because it's a shorter password, but it's got every type of character type that I mentioned. It's and 2 is fine also. Yeah, because 2, even though it's all lowercase, is long enough. I think it's about 19 characters, so it's above 18. And even though 3 is short, because it's got capitals and exclamation marks and punctuation and so on, that's okay. My password is obviously not allowed. It's too short, and also it has the password in it, which is far too common. And also the 4th one looks to be long enough, but actually it's actually a popular. I've never seen it myself, but it's apparently a popular term from a web comic. The XKCD. I've not clicked on that. So we're talking about SSH keys, and so this will be something that you're probably already familiar with, the part where you create the key pair on your local machine, and then you upload the public part to Archer 2. So that would be something like this. So I'm just moving to my account page for this training course, MRBTA082, and I've actually got 2 credentials, which are the public keys, which I've uploaded, and I think that's the one I uploaded a few days ago. And you would do it by clicking on this add credential button here, and then you'll be invited to select the file that's on your hard disk on your local machine. And you can also delete the credential if you want. And once you've set that up, and when you log in, first of all, you would need to view your login account password, because when account is first created, a random password is assigned initially, and you would need to view that first. So if we were to do that, this isn't my password. I should make clear. So that was my initial password. I've since changed it, of course, but this is the sort of thing you see, which this is the process that most of you have already been through. And this is the command that you would use to log in to Archer 2. And here you would specify the path to your newly created SSH key. And then this is just a bit of text that tells you when you do it for the first time, you're prompted for your passphrase. Well, then you're prompted for your password, and then you have to go through like the password change a process where you put in your initial password twice. The second time it's referred to as hold that password, and then you put in your new password, and you have to do that twice to make sure that there wasn't any mistakes when you were putting it in for the first time. So there is. I'm just going to show you how I do this. So I'm just logging in now, and if you notice that I'm just typing in quite a simple SSH command, and I've gone straight in, and I've not had to do anything. I've not had to submit any passphrase or password. You might wonder, well, what's going on there for me? So what you can have set up in SSH is something called a config file, and normally it's just called config, and it will be in your .ssh folder, and within there you'll have the details that you'll have things like the SSH key and the particular username you'll need to access particular remote clients or machines that you're connecting to remotely. So I'm just going to give you an example of that in this config file. This isn't the config file I actually use. You can see, because I've put the suffix _ TA082, it just contains the details for my training account. So this is the kind of thing you've got in here. Whoops, I just go back. So it starts with a map. So whatever I type in when I do my SSH command, because I've got this wildcard here, all of these options will come into play, and I'll explain those in a minute. But when I do SSH TA082, it then says it goes into the config file to so someone, Ruben, I think my SSH key is for the host 4 cabinet. Is that what the 4C means to Archer 2? Will that one still work? Yes, it should still work. The 4 cabinet machine, if that's what that's referring to, no longer exists. And as long as you've uploaded that public key up to your training account within Safe, then that should be okay. I guess you can easily test that. I assume you've been able to log into your Archer 2 training account, so that would. So anyway, back to this. In my config file, you can see I've got my host TA082. So this is underneath. There are the options that come into play when I type SSH TA082 at the command line. So it knows what my host name is going to be. That's the Archer 2 address that I showed earlier. It knows what my user is, my username. And it knows where to go to get my SSH key. So that's the private key, so that then it can confirm with the public key that's been uploaded to my account previously. Now you'll notice that amongst these other options, the ones that always apply, I've got things to do with something called an agent or a key agent, add keys to agent or update host keys and so on. So and they use the keychain. So these are the options, the config options that allow me to cache the passphrase on my local machine. So when I log into Archer 2 using my TA082 account, it knows that my passphrase is cached, so it can use that, and I don't have to submit that every time. I've got a number of other options, these forward X11 options, which I've put here, and this is because I trust Archer 2. I'm happy to allow it to show a visual user interface. So I have these options set to yes, so that if I'm logged into my Archer 2 account and I need to run something, maybe a profiling tool to see how well a particular code ran, and that has a visual user interface, then that will display on my local machine, and I trust Archer 2 to do that. Otherwise, if you didn't want to do that, you might, if you profiled a code, say if you profiled a particular code run, that might generate a data file. Then you would have to download that to your local machine, and then you would run the visual interface, whatever it was, such so that it was entirely contained on your local machine. I've got these other options here, these ones, control master, control path, and control persist, and so on. And it's these that allow me to not have to submit my account password. And what those options do, they create something called a multiplexed SSH session. So that will exist probably for a few hours, maybe 6 hours, certainly not for a whole day, because then it'll probably be closed on the Archer 2 end. But if you were working on something and you're having to go into various accounts, or that's quite well, if you're having to log into the same account from various points, that's quite handy to have these options, because it means that you don't have to submit your account password during the couple of hours that you are working and require access to Archer 2. So there is a caveat with using SSH multiplexing. You'll notice these commands up here. I'll just show you what those do. So I have something like SSHO check host, which in my case is TA022. So that just tells me which multiplex sessions I have running at the moment, and I've got one. And if I wanted to stop it for whatever reason, I would do this. So that's closed it. And now when I log in, it will actually prompt me for my password, because I've killed the multiplex session. It hasn't prompted me for my SSH key passphrase, because that's cached in the key agent. So I'll now have to type in my password. So I've done that and I've logged in, and now that's established, that's re-established my SSH, sorry, my multiplex session. So just to prove that, I can log straight back in. So the reason why you might want to close down and terminate your multiplex session will be if your password's expired and you need to go through the password change procedure. I found that doesn't work if you've got a multiplex session, so you need to shut that down. But your password is good for a year. It will expire 12 months. But I mean, if you wanted to change your password before then, you would then need to close or terminate your multiplex session. You would actually need to go back into your config file and comment out these control options, just so that you can change your password properly. Okay, so that's just a bit more information. I'll post those options in the SSH config file into the Etherpad, so that people can look at them later if they're interested. But I found that personally, in working in HPC, quite a useful thing to be able to do. It saves time, and it makes it easier. I mean, there is a slight downside, is that it can cause you to forget your password, because you're not reminding yourself so often. So we'll just talk about data transfer, because that might be something that you will do when you start to copy files into your account. Normally, when you're on the login node on Archer 2, you can just, if you wanted to clone a GitHub repo, for example, you can just do that directly from the login node. But I guess this section might apply if you've run some jobs and you've created some output data, and now you want to save it and you want to copy it to another location. So you can do that with using something called the secure copy command. And so the way that might work is something like this. So if I come out of here, and if I just create a temp folder, and I go in there, and I'll just create a file, say that, I just touch it, it's just a small file. So if I wanted to copy that to a location on Archer 2, I might do something like this, and this is I can use TA082 here because I have this set up in my SSH config file. But if you didn't have that, you would type something like your username, say, and then you would have to do login.archer2.ac.uk, and then after the colon, you would then put your path. I've done something called like a squiggly character, which is a tilde, which indicates my home folder. Which, if I was to write out in long form, it's just like this. So that's the sort of thing, and oops. So that's the sort of command that would do a secure copy of the data.dat file into the home folder of your training account or whatever particular account you have on Archer 2. I would have to obviously change that, I think. So that's the way you would use SCP. There's also rsync, which maybe you'd use that from within your Archer 2 account, and so you would have some a local. You might have another folder somewhere that's also on your Archer 2 account that you want to make sure that everything is backed up to, and then later on you might do a secure copy from your Archer 2 account back to your local machine. So rsync just allows you to specify it allows you to specify two areas, so one of which is a backup area and the other would be your live area. I'm talking about like a path to a directory, and you've made changes in your live area and you just do an rsync, and then that would make sure that those changes then get copied across to the backup area. You can click on this link here, and this takes you to a place in the Archer 2 user guide, and that can give you more information in here for how to do data transfer. There's a couple of points about the best practice for, you need to identify how much data you are creating and which bits of that data are absolutely critical. Normally, if you're doing research, then you'd be interested in what you want to do is copy that data which is required in order to reproduce your work. So that's what you need to think about. Normally, when people apply for time on Archer 2, they have to do a part of the application which is showing that you've thought about how much data you're going to need to take off Archer 2 during the project, and how frequently you plan to do that. So you're aware of which data you need, and you make sure that you have a copy of it before the project comes to an end. Obviously, it helps if you minimize the amount of data that you are transferring, and we recommend that you archive your data in that you compress it into a single zip or tar file. That makes the action of transferring things a lot easier, because then there aren't so many metadata operations required. So what I mean by metadata is, say if you had 1,000 files that you wanted to transfer, then whichever command you run to do that, it's going to do a bit of overhead for each of those 1,000 files. So if it's something like, if you're needing to encrypt each of the files, for example, that can amount to quite a bit of overhead. And there's something here about sometimes if you're compressing it, it may actually, the time it takes to compress something may be longer than the actual transfer time. So you would want to think about that when you're transferring files. If you've got a whole batch of data you want to transfer, you might want to do a short test. You may want to test a few files to begin with, and then time how long that takes. So you then would know how long it would take to transfer all of the data that you intend to transfer. There are also overheads associated with encryption, but with these tools, you can choose which encryption algorithm you use. If you're interested in a bit more information, you can normally find out by consulting the manual page. So, for example, for SCP, there's a manual page there that you can read through, and you can consult the cipher option and so on. And you can also, I'm running Mandow on my local machine, but you could, if you're running a command from the Archer 2 logging node, you normally find that the manual command will work for most things. If not, you might be able to do something like this, for example. Oh, a legal option. So I'm just trying this on the fly. I don't know if this would ever work. So it looks like you just need to use man if you're interested in finding out more information about the secure copy command. So there's a bit of an exercise for you, which will involve you looking at the zip archive file. So using the documentation above, so that's also going to one of these links. You create an uncompressed zip archive file of all the data within a directory called, this is just a scenario that's been sketched out here called large data output. What command would you use to verify that the archive file you've created is not corrupt, so you can safely delete the original data? So with this on your local machine, or you might have to then do a man zip to consult what's possible. So I just I think I'll just stop to check if anyone's got any questions about logging into Archer 2 and setting up the Archer 2 user accounts, because that's the first thing I covered, and also if anyone has any questions about transferring data to and from your account. I just check that no one's got any questions about that, and if not, then I'll give you a few minutes to work out a solution to this question about how to create a zip archive. The question that we were working on was how to archive this data using the zip command. So you can use the -r option to archive data recursively. So you just give the path to the folder, and that folder will contain files, where it contains subfolders that also contain files, and so on and so on. But it will work through all of that and archive it, or put it into one file, one.zip file. And you use the -o option to make sure that it's uncompressed. And then it can be validated with the -t option. So what that is doing is that within the zip file, it's got a directory list of its contents, and then it's making sure that for each entry in its listing that there is an actual file that maps to that's within the archive. So that's just to guarantee that it's not being corrupted. And this might happen if you copy the zip file to a particular location, and unbeknown to you, the session, that the terminal session that you had open had shut down, but a partial copy had taken place, but you weren't aware that the session had been terminated and you with this file, but actually it's not a complete archive. And so if you were to do the zip-t option, it would find that one of the entries in the directory, which is probably the first thing that is set up in the zip file, doesn't map to actual data within the zip file. So that's just explained that thing. So that's the first part of this course. So we'll just have a break for a few minutes. Okay, everybody, I'm going to return to the course. We're going to talk about the Archer 2 hardware, and as before, share my screen. So, right, I take it there that everyone now can see a screen which is, well, you've got two titles: Archer 2 for software package users, and an overview of the Archer 2 system, so everyone can see that. Okay, so this part of the course, we're just going to cover the architecture of Archer 2. It's a Cray system, well, I should say a HPE Cray, because Hewlett Packard Enterprise merged with Cray, and the particular type of machine is an EX. And we have a number of different node types within the machine. We have login nodes, which is what you access when you first access Archer 2. You have compute nodes, which are the nodes to do your computationally intensive work, usually running a parallel code. So it's something that can then run something on all the cores of all the nodes that you happen to be using. And then we have a third type of node called data analysis, pre or post-processing nodes. So these are nodes that you would use to do some work which maybe is too intensive to do on the login nodes, because the login nodes, the first thing you should be aware of is that there are only 4 of them on Archer 2, and usually they're not all available. So there may only be 2 login nodes in your one time, and these are a shared resource. And so all of the users that are currently logged into Archer 2, so that might be up to 100 people, are using those nodes. So if you do anything that is occupying a significant number of the CPUs available on the logging node, and there are 128 of them per node, you will then be impacting other users. Other users will be finding, for example, when they try to do a directory listing of their area, that simple command is taking a long time to return any output, and so on. So for certain types of work, if you've run a code on the compute nodes and you produce some sort of output and you need to run an analysis script, and it's having to do an analysis on gigabytes of output, so it's quite a lot, you would run that on the data analysis nodes, and then that's a part of a node which will be assigned to you, and you can do with that what you will. I say part, you specify a number of cores and a certain amount of memory that you tend to use. You may also need to do pre-processing, particularly for certain codes, can have a very complicated compilation procedure, which can take an hour or two. There's a particular code called CP2K, which is a molecular modeling code, and that involves compiling lots of other components before you compile CP2K itself. So something like that, it's useful to actually run on the data analysis nodes, because to some point you would need to automate, you need to specify a script to do the compile. So automatically it becomes easier to reproduce your work should you need to. So here's a schematic of those nodes that I've just been talking about, the ones that you log into. And then when you run things on either the data analysis nodes or the compute nodes, you interact through something called the Slurm batch system. We'll talk about that in a subsequent chapter of this course. Also shown on the schematic are 3 types of file system. There's /home, which is what you will log into automatically when you access your Archer 2 account. And that's a file system that is backed up. So that would be normally where you would put your source code for the codes that you intend to run on the compute nodes. And then when you compile them, though, you would normally make sure that the executable that's compiled, or the library, is copied to somewhere on /work. Because on the compute nodes, you can only access either the /work file system or solid state. So a lot of users, when they first use Archer 2, will run up into a problem when they submit a job to the compute nodes. But on the job script, it will be attempting to read something from /home, and that will fail because the Archer 2 is put together such that the compute nodes do not have access to /home. There's this third type of file system that I've not really talked about, called a solid state file system, and that is that's a bit smaller than /work, and it's just a little bit faster to access. And that's not that's only available in a kind of testing capacity at the moment. But in due course, that will become available, and you'll be able to specify what how much of the solid state drive you require on a job by job basis. But normally you would just use /work, and /work is a scratch file system. Any data saved there isn't backed up, and so you would need to, once your job is finished, make sure that you've backed up any data that you will need elsewhere, and probably you'll back that up to somewhere off-site, as it were, to somewhere external to Archer 2. We'll just talk about now the compute nodes. There are nearly 6,000 of them, and so each of those nodes has 128 cores. So what you actually have on the node are 2 processors, and these are 2 AMD EPYC Zen 2 or Rome processors. Each of those have 64 cores, so you have 2 of them. That comes to 128. They're arranged such that they form separate NUMA regions, and normally, if you were wanting to run something in parallel across a compute node, you might want to arrange your tasks so that they're evenly distributed across the NUMA regions to maximize memory bandwidth. The amount of memory on a compute node is 256 gigabytes. We also have high memory nodes. We have about 500 of those, 584. So that's double the amount of memory, so 512 gigabytes. And so we have specifications for the memory bandwidth and the interconnect bandwidth. So Archer 2 uses something called a slingshot interconnect. So this is the communications channel between the nodes, between the compute nodes that form Archer 2. So the storage, which I just mentioned, we've got home, work, and something called RDF, which is external to Archer 2. It's the remote data facility. So that's something you would use for long-term storage. So that's again offered on a case-by-case basis. It's not, if you apply for time on Archer 2 and you get that time and you get a project set up, you wouldn't get RDF as standard. That's something that you would then have to ask for in addition during your application for time on Archer 2. And that's just a long-term service for long-term storage. So I look at detail at the home and work file systems now. So on home is where you store your critical source code, and this is backed up regularly, and we have about 1 petabyte of usable space. So the format that you're given when you have a project on Archer 2 is as is outlined here: /home to indicate the home file system, and then your project ID and a sub-project ID, and then your user ID. Now, normally the sub-project ID will be identical to your project ID, but not in all cases. So in your training account, you'll see that you've got TA082, TA082, and then your username. So this is just a note about the source of confusion between your home file system and your home directory. The home directory is a Linux concept that you are placed into when you first log in, that is stored in the $home environment variable. And that's the CD tilde, that's the tilde character that I mentioned before. That's shorthand for your home folder. Now, you can view things, you can view how things are set up regarding your file systems on Archer 2 within your safe account. So I'll just show you that now. Whoops, I've gone on to Rubens, but that's my training account page, and you can see that I've got these are the resources I'm using on the home file system for the training account project, the TA082, and I got a quota of about 100 gigabytes. And then on /work, I've got 5 times as much as the quota, but my usage level at the moment is minimal. I've only got 9 files on /work at the moment. You'll also see I have a budget. You need a budget, a non-zero budget, to be able to run things on the compute nodes. And you see at the moment it's 19.9 CUs. CU standing for compute units. 1 CU is 1 node hour of use. So if I was to run a job that used 10 nodes and ran for an hour, I would be left with 9.9 CUs of budget. So let's get back to the course there. So there's just a bit note about, you can have a more complicated project set up. You may have subgroups within a project, and this is how it works out. It's just the third folder on the path in the home file system. We'll just get a different name. And then if you want to restore things, well, if you want to check that the data is being backed up, you can look at the snapshots that are taken. And so those different snapshots on the home file system are taken at different frequencies, got weekly, daily, and hourly. And then I think which snapshot applies to you depends on the particular home file system you're using, whether it's home 1 or home 2 or home 3. So we can find out what we have. If I can log back into my training account. It seems to be a while since there it is. I've still got the multiplex session set up, so I can just run that. It tells me I'm on home 3. So that's the snapshot I would look at. So the work file system is designed for high performance parallel access, and that's a primary location that jobs running on the compute nodes will read data from and write data to. They could also use the solid state drive. Well, potentially, later on when that is more integrated into Archer 2, you'll be able to use that be available as standard. So it's based on the Lustre parallel file system technology, and what that kind of means is that the Lustre file system is made up, in terms of hardware, it's made up of something called object storage targets. So these are different sets of hardware that when you write a file, if it's a particularly big file, you can specify how many stripes that should be broken down into, and then each stripe will be written to a different object storage target, and you can specify how many targets you want to use. So you might, I think there's like a stripe size and a stripe count, and if you specify a -1 for the stripe count, then you're using the full parallel capability of the Lustre file system. You're using all the object storage targets, but there are particular commands to do that, to specify how things would be striped for a particular directory, such that any files or subfolders within that directory will inherit the same stripe settings. Again, this is just showing you how things are set up as regards the path on /work, and you can see it's very similar to the way it's done on /home, well, identical really. And on /work in total, you have about 10 times the amount of storage space that you do on /home. I'm trying to remember how much it was on. Yeah, it's 1 petabyte on /home, so it's nearly 11 petabytes on /work. Yeah, so that's just a note saying about what I explained earlier. Files on the home file systems won't be visible from the compute nodes. And these are a few commands that you can run to check your quota to see how much you have available. So if, for example, if I was to do this command, what I'm doing here, that looks a little complicated. The $ID-group is just giving you the ID number that matches the project group, and the -HP is saying, yeah, how much quota I have for the project on the work file system. The H just puts it in, well, human readable terms. So you can see the output. I've got a G here to indicate that it's gigabytes. That's the amount I've used. And then you can also do the similar command, but on the user basis. You've got the -HU and then your username. So these are things that you can check what quota you're using, and well, you can see which quota or limit applies to you and how much data you've already used. Let's just run a few of those in there. Oops. In here. Yeah. So I've done something being specified. So I think I've done too far. Yeah, it's just, so I want to go somewhere on /work. So where I'm at the moment, I'm in home. So and that will be my username. So there. So I can go back to that command, but I'd missed off to indicate the location I'm interested in. So this is just my current working directory, which is on /home, and then it will give me. So I don't have a quota set for me, but there is a limit attached to the project as a whole. This is the TA082 project, and it's 500 gigabytes, and I'm just using a paltry 74 megabytes. Not much at all. And then you can also just run a command like this. So I'd have to change that a little bit. 282. And it's complaining about something. Oh yeah, I got some output from there. There we go. It's another bit about sharing data with other users. So on both the /home and /work areas, there are what is known as what I refer to them as inner and outer shared folders. So what we've got here, that is the inner shared folder. So it's inside. You've got TA1, T01, and then shared. And data placed in here can be shared with other users that belong to the same T01 project. But if you wanted to share data with users that belong to different projects on Archer 2, you'd use the outer shared folder, and that's what I mean by outer. So it's one level up in that file path. And then you can do things and so on like this. And so when you share data, so if we go back to the inner shared folder, so that's sharing data within users of the same project, you do something like this. So you create a folder within shared, and then you copy across your data, and then you do something like this command. That sounds quite complicated. So this is just a standard Linux change mod command. You've already copied the data over, but now you're setting the permissions just to be certain that the only people that can access this interesting hyphen data are the people within the project. So I'll just break this command down. So G plus RX means that only people within the group T01 will have read permission for those files within interesting -data. We've got the -R to make sure that these permissions are changed recursively. So that's for all the data files within interesting data. And the X allows people within the group to be able to access the subfolders within interesting -data. Now, similarly, we want to take away those permissions for people who are outside of the group, so people belonging to other projects on Archer 2. So this is what this O standing for others, and the hyphen or the minus sign, meaning take away these privileges. So that's the read, the write, and the execute privileges for the files that are within inside interesting data. So similarly, if you were then wanting to actually share data in the outer shared folder, so you want to share data with other users outside of the T01 project, you would do your change mod command like this. So now we're making sure that both group users and others, people outside of the group, have read access to all of the subfolders and folders within more interesting data. Typically what happens if you're using Archer 2 and you run into a problem and someone on the help desk is trying to help you, and it's not clear what's going on, and we need to take a close look at maybe your input files or maybe your source code, we would ask you to copy that, to copy those files into the outer shared folder, because the people that are on the help desk won't belong to your project group. They will belong to their own admin group. So it allows them to see that, whatever it is, they allows them to see those source files or whatever the input files that will help them solve the problem that you are experiencing. So that's, that's a fairly complicated topic for first-time users. So I'll just pause there and check if anyone has any questions about this part of the course. Is everyone okay? Am I okay to carry on? Okay, I've got a yes from Ruben. So and no no's. Yeah. Thanks, Alistair. So I'll talk about the system software. And what we have, it's actually not mentioned on here, we have something called Cray Programming Environment Releases. And we'll be a bit later on, we'll be covering module commands, but basically there are 3 releases currently available on Archer 2. So that's they have various version names, and there's a default one, but within each release you have 3 compiler suites. So you have the GNU compiler suites, that's GCC, G++, and G-Fortran, and then you have the Cray compilers, also for Fortran and C and C++, and you have the AMD compilers. And AMD are there, well, because the hardware itself, on the compute nodes and the login nodes and the data analysis nodes is AMD hardware. It's AMD CPUs and processors. So above, so next in importance are the parallel libraries that allow you to run parallel code such that they can communicate the different parts of your tasks, your parallel tasks can communicate with each other. So we have the Cray MPI libraries, and we have different libraries depending on whether or not you're using the AMD or the Cray or the GNU programming environments. And you have things for doing other types of communication, partitioning workspaces, such as what you do if you're using global arrays. So this is like you're communicating via memory rather than doing point-to-point messaging. We also have scientific and numerical libraries that will also make use of the parallel libraries. So we have the ones for doing linear algebra, the BLAST, the LAPACK, and then things for doing like fast Fourier transforms, FFTW. And then we have, I don't quite know why HDF5 and NetCDF are there. So that's what you would use when you're reading and writing files and you want to do that. So you're managing that in parallel. So if you do a write to a file, you might want to do a collective write. So it's basically all of your MPI tasks have to do this write, and they'll be writing to a particular offset to the file. And then we have various debugging and profiling tools that allow you to step through your parallel code, such as GDB for HPC, profiling tools such as Cray-Pat. So you can run these sorts of things, and they will tell you which areas of your code are the hottest, and by hot I mean where most time is spent. So sometimes there's a kind of standard rule that 80% of the runtime will be spent in 20% of the code. That's that kind of rule of thumb that often applies. We have other things, profiling tools such as we have the ARM map tool and ARM DDT, which is a debugging tool. Such tools, I think we have license restrictions on those. I think they are licensed to use on 64 compute nodes. We also have a Python 3 environment. So we have a module called Cray-Python, which you can load, and then that will give you access to NumPy, SciPy, and MPI for Pi, which allows you to do MPI parallel communication within a Python environment. And then we have an R environment, R being it's an environment for allow you to do statistical based computations. So there's a bit of a note. I mean, I don't know if anyone of you have had any experience with the Archer 2, the precursor, the machine that came before Archer 2, which was called Archer. That had Intel hardware, so we had an Intel programming environment instead of the AMD environment that we have on Archer 2. And so compared to that, we don't have Intel compilers and we don't have MKL libraries. But this needs to be updated because this is not true. I'll have to make a note to do this. We do have ARMForge, which includes DDT and MAP. We do have those on Archer 2. It's just, as I said earlier, there is a restriction on the number of compute nodes that you can do your profiling on or your debugging on. And in addition to that software that I've just outlined, there are various research codes that we have. So we have, I think the most popular code in terms of node hours is VASP, which is a molecular modeling code, and then we have lots of other similar codes like CASTEP and CB2K. We have some codes for engineering, for modeling CFD or computational fluid dynamics, biomolecular modeling, GROMACS and NAMD. There is a GROMACS example that we'll run through at the end of this course. And then we have code for doing Earth system modeling. So for modeling the climate over the Earth, there's the Met Office code. For doing ocean modeling, we use NEMO. And then we've got some other scientific libraries for doing specific linear algebra things. There you go. And then finally, we've got some other software tools, such as PowerView, which is like a visualization package, PyTorch and TensorFlow, which are used for machine learning. I mean, that's not a great thing to use on Archer 2 because it is a CPU-based system. We have another machine that we support at EPCC called Cirrus, which has GPU nodes, NVIDIA GPU nodes. So generally, I mean, machine learning is a better fit for a GPU-based machine. VMD, I think, is some molecular modeling visualization tool. So generally, I mean, a lot of the code is you don't require a license to use, but something like VAS, for example, you will need to demonstrate that you are a licensed user, and you would do that through the safe typically. So if I can go back through, just an example, I've gone into the safe, and this is my the account page for my machine account on Archer 2. You would do something like this. You go to one of the buttons along here, and you would click on the request access to package, which I'll do that, and then you select the package group, and I've got a drop down list of all the various codes on Archer 2 that do require that you show that you have a license. So I've got VAS 5 and VAS 6. So if I clicked on VAS 6 and go to select, I would then in this box here, I would have to type my license number. Yeah, I mean, if you're working in a research group, you'd probably have to give the contact details. You have to ask your supervisor, whoever that is, for the details of the license, and you would have to say, you have to give the name of your supervisor as the contact on the license. So that's the steps that you would have to take in order to be able to use a tool, in order to be able to use some of the licensed software such as VAS. So on Archer 2, we also support something called Singularity containers. So it is possible to run a container on the compute nodes, and even if you wanted to use that, if you wanted to run a parallel job, that can be done also. So Singularity containers, it's not akin to a virtual machine. It's not like that. It's not as separate from the host machine as a virtual machine would be. It's something that actually shares the kernel part of the operating system of the host. And so when you build a container, you would specify the operating system for it. It would have to be a Linux-based operating system, and this allows you to create an environment that may be useful for doing post-processing, or it may be you may be able to use it for doing the actual computational work. Using containers makes it easier for you to move from HPC machine to HPC machine, but that's a whole topic in its own right. There is in fact a separate course that we give on Singularity containers at EPCC. So just some key points then. Archer 2 consists of three types of, of various types of nodes: login, compute, data analysis, and then we have various types of file systems. We have a wide range of software available in Archer 2, and you kind of interact with it from the command line on a standard Linux environment. So I take it if there are no questions, I'll move on. But before I do, I'll just make you aware of the documentation that is available for Archer 2. I think it's because I've mentioned a few things. So we've got this page here, this docs.archer2.ac is where all the documentation lives, and we've got a quick start guide. So that kind of minimizes the amount of material you need to know to get up and running on Archer 2. And then we have something that's more in depth, such as the Archer 2 user and best practice guide. So if you go into there, you've got all the details of the software environment and so on. And so this will be all, will cover all the material to do with loading the various modules that are available on Archer 2. I'll go into a moment, and then we've got the information about containers, which you can find out. So I mentioned this because you've got much more in-depth information here, and I realize I only mentioned it briefly. So if you are interested, this is where you can go to find out more about it. If you're interested in the profiling, what you can do to profile codes on Archer 2, it's all contained down here. And you've even got a section down here on the right to do with ArmForge. And you can go to a particular page and you can find out how you can use DDT, which is the bugging tool, or the profiling tool, RMAP. There's also the main Archer 2 website. Again, it's what you just has the address that you'd expect, archer2.ac.uk. What is a useful part of this is the training materials repo. And on here, you've got access to the training materials for all the courses that have been held in the past. So we've got specific things for ArmForge, and I think if I clicked on there, you can go to the original recording that was made. So I mean, this is stuff that you can do in your own time. And probably down here, there's also a course to do with using Singularity containers, and here it is too. You can click on that link, and then yeah, you can also access the course materials. So that's quite, I think, a really good resource. So you don't have to be available when a course is held at a particular time necessarily. You can always just go to that repo of training course materials and then access that at your convenience. So I'll move on now to the Archer 2 software environment, and we'll look at the various software modules that are available in Archer 2, and these are put together using something called the LMOD system. LMOD is just it's basically the language that we use to specify the module files. When you load a module, it will typically change your environment settings. So it will change things such that it can now find certain libraries or certain executables because they've now been added to your path. So we can check if we can log into your Archer 2 account and check what modules you have loaded. You can just run module space list and you can see that you should get this is the output you should see. I just check if that everyone is okay to do this. If everyone has any problems in running this command, you can just let me know in the chat window. But I'll just talk through what you should see. So by default, the Cray programming environment is loaded, and we have CCE, that's the Cray compiler environment, version 11. We have the Cray PE, the Cray programming environment, and we have specifically for the Rome hardware that refers to the AMD code name for the hardware on the compute nodes. The libfabric is used for the interconnect, and that's the communications protocol that we use. OFI, it doesn't really stand for anything. I mean, I think it's Open Fabrics Initiative. It's not particularly meaningful. You've got a choice of comms protocols. You can either use OFI or UCX. But anyway, that by default you use the OFI protocol. We got the Cray MPI library. We got the scientific library and various other things. I think Bolt is a tool that you can use to help write your submission scripts for when you want to start a job on Archer 2. I mean, if you make a mistake or if you get like a set of modules, if you go through a number of module load commands and you want to start again, normally you can just do a module restore to go back to where you were before, or you could do something more brute force. You can log out and log in again. You should have restored the initial module list that way. But if you type module avail now, you'll be able to see all of the modules that are available on Archer 2. So if we just go through these, there's a number of Python modules available. One's for Matplotlib, which is a wonderful piece of software. And then there's NetCDF, which is for doing parallel I/O. I think Seaborn is also for doing plots too. I'm not sure. I've never used that. We've got some core libraries, which are mainly for doing types of scientific calculation and linear algebra, or being able to do some work with a grid if you want to split it up or do a partitioning of any kind. We've got the applications, CodeSaturn, which is like CFD, CP2K, and so on. And then we've got various other utils. We've got CMake, which is how to describe that? That's basically a tool allowing you to decide how code is compiled. So typically you would write a set of CMake scripts that can interrogate whichever hardware, whichever machine you happen to be on, and then it would work out how to put together the build scripts to actually then go away and build the source code. And then we have various other things for visualization and so on. And we have some more file IO libraries. We have the Cray performance tools. Some of these are actually can't be used because, well, not yet anyway. It is planned for Archer 2 to have GPU nodes, but it doesn't have it. It doesn't have any such nodes at the moment. But when it does, you'll be able to use this type of module. But until then, you can't. So we've got some various. We've got some variants of the Cray MPI library, and a few other tools down here, and it goes on and on. So again, to come on to actual licensed software, I think, yeah, I went over that. So some of the software will not actually require user to have their license checked or before they can use it on the surface or on the service. So that is, we've just been over that when I showed you how you can request access to a package group. This is not all of the software modules on the system will be listed on Module Avail. So sometimes may not be able to available to load until certain other modules have been loaded first. So you can test this out with the Cray NetCDF module. So you can't load that until the Cray HDF5 module has been loaded. If you want to search all modules, you need to use the module spider command. And that, if you do, will then also tell you the other modules that need to be loaded, which it does down here in the output. So I think we'll try and work through these exercises here that come under loading and switching modules. So we do a module list and we do a module load GROMACS. So I can do that just here. So I do a module list and a module. So it's telling you what's happened under the hood. That there's other modules that have changed. So it's basically this version of GROMACS that I've loaded was built using the GNU compilers. So underneath it changes. It swaps out the Cray compilers with the GCC compilers, GCC version 10. And then it also changes the programming environment from Cray to GNU, and then obviously there are also updates in the Cray MPitch library and so on. So now if you do a module list, you should see there's a 14th module now called GROMACS, and it's version 2021.3. You can then interrogate that module a little bit. I think sometimes there's a reasonable amount of help. So if you just do the module help command, this just tells you some extra information about it. That the MPI executable is called GMX underscore MPI, for example. And that there's also a serial version. We do have a GitHub repo with the build instructions for most of these applications, which may be useful to consult. If you're interested in trying to use a particular application in the same way that it was built on another machine, perhaps, or it was close as you can get. So I can show you where that is. So we've got a GitHub repo called build instructions. I'll post that. And then if you go to apps, and we've got a whole load of applications, and you go to GROMACS, and we've got the build instructions for various machines. But if you went to Archer 2, I think that version is slightly earlier. You can then see how that GROMACS code was actually built. What's on here, I would guess, would probably also apply for 2021.3. I'll just post that link in the chat. It's quite a useful page, quite a useful repo. So again, yeah, I've actually been over this part already, the licensed software, getting help with software. Yeah, wait a minute, I can get here. So I talked about the various types of documentation available in the docs.archer2.icu.uk. It's also broken down. There's a research software section, so it's broken down by codes, and we can go to GROMACS. It should be on here. There it is. And so we've got some more information about GROMACS, which gives you also an example submission script as well, so you can see how to run it. We also have, as I say, we have pages for other codes such as Nemo, and this was probably quite a useful page to read because Nemo is fairly complicated to get running. Usually people typically run things known as heterogeneous jobs, meaning that you have more than one executable that runs on a compute node. So this page has a lot of detail on how to run a Nemo job. But generally, you can move around here and find lots of information. There's stuff to do with particular software libraries. And then we've also got the various tools for data analysis. We've got the ARM Forge tools, ParaView, which is a visualization tool, and R, which is the statistical package that allows you to do stats. So that's if you have a problem, generally you might be able to find the answer somewhere amongst the on the Archer 2 documentation website. If you don't, if you still have a problem, you can raise a query via your SAFE account. So going back to your SAFE, you would go on help and support, and you would click on submit support request, and then you would give the problem a descriptive title, and then you would type in all the details in here, and that will go to the help desk and then be assigned to someone, and then they would get in touch via email. So I think that brings us up to lunch. Does anyone have any questions about the material that we've just been through? Okay. Okay, so I just go over what's going to come up after lunch, but I guess we'll break for 12 and resume at 1 o'clock. And so what we'll be doing after lunch, I think, is like the main part of the course. It's going through how to write a job submission script. So how to work with the Slurm batch system and how to control the job once it runs and how to find out what resources it uses. And that's I think the heart of the course. And then after that are some kind of light sections, which, how to be a good Archer 2 user, which basically means don't monopolize the logging node. And then there's other things about using safe. So Benil has asked a question, will module load reflect in other job nodes as well? So I'm not sure what you mean by that. If you're saying, if you do a module load within your job submission script, then the changes to the environment that are caused by that module load will apply to your job, and it will apply to all of the environments and all of the compute nodes that you're using. If that's what you mean by that. Okay, yeah. So we'll show how to do that when we go through some examples of scripts of the Slurm scripts. There'll be module load commands in there, and I think we'll start with, we'll talk about how to the next steps you may take in using Archer 2, and I think we also go through a kind of GROMACS example. We'll run a job and show you how that works, and then that's the end of the course.